This is a video to remind you about creating sliders in GeoGebra as a way to dynamically explore shapes of graphs. Specifically, this video is about looking at exponential functions. Remember that an exponential function is any function of the form f of x equals b to the x, where b is a real number. We already discovered that b must be positive and not equal to 1 in order to create a well-defined exponential function. The question you'll be exploring now through GeoGebra is how different values of b affect the graph. For example, how does the graph of f of x equals 2 to the x compare to the graph of g of x equals 3 to the x? And how do those then compare to the graph, say, of h of x equals 4/5 to the x? You'll answer these questions yourself, but I wanted to give you some tips on using GeoGebra for this. I'll go in now and start up GeoGebra using the web version. Remember, of course, that you want to actually use GeoGebra Classic, not just the graphing version. As you know, I'm not fond of having the grid in my way, so I will turn that off. A couple of other settings that I will go ahead and make here with the settings button and then changing it to the global settings. First of all, I'm going to set it at 5 decimal places of accuracy, and then just to make things a little more visible on the screen especially, I'm going to change it to 24-point type. I'll zoom in just a little bit here, or zoom out, get some numbers in here the way I want. If I'm not seeing the values that I want on the x-axis, for example, if I zoom out just a little too much, it doesn't show the markings by 1s, but instead by 2s. There is a way to set that, but I think for now I'm just going to get it in a place where it's showing me that. So now I come over here and I type in my function, and we'll start with just f of x equals, and I will put b to the x, where b is going to be a parameter that I get to change. And as soon as I hit enter, GeoGebra realizes that I probably wanted a slider in order to be able to change things and move stuff around. And as we saw already, we do not get a graph when we use a negative base. We do not get an actual proper exponential function graph if the base is 0, and we do not get an exponential function if we let the base be 1. So that's what we had talked about already with regard to the base being positive but not equal to 1. Something then that you'll want to go do with your slider is to come in and change the settings. So I select it, go to the settings, and right here I want my minimum to maybe be 0.1. I'll let my maximum go all the way up to perhaps 10. But then I also want to set the increment so that I have a lot of control over moving that around and changing it. Later you may even want to increase the accuracy on there by making a smaller increment. So now I'm able to sit here and change my b. I never lose the graph, so to speak, because I'm not allowing those negative values anymore. And as I move that slider around, which I can do with my mouse or trackpad, or I can do simply with the arrow keys. Once I've clicked on it, I can go a little slower with my arrow keys. It's going to allow me then to see the differences among the different bases on my exponential functions. You can even hit this little button here to animate it and have it go through back and forth all the various values of b that you have set up for it. I personally like to just control it myself, but it's kind of cool to watch. Once you have figured out how b changes the shape of the graph, you'll possibly want to explore transformations of those graphs for a specific value of b. And you can create some additional sliders for this. Remember when we were working with trig functions, we had used the parameters A, B, C, and D as capital letters to denote the various things that could change the period or the phase shift or the amplitude. However, with GeoGebra, you're only allowed to use lowercase letter for parameters. Uppercase letters stand for points. And also remember that we've assigned the parameter b as the base of our exponential function. So we're not going to just get to use straight up a, b, c, d in lowercase. And we may want to instead change the form that we explore as a times b to the exponent of c times the quantity x minus h, all plus k. You might be wondering about the h and the k. That actually comes from older classes that existed before pre-calculus, where we studied conic sections, and h and k were the letters that just happened to be used for the shifts in both the vertical and horizontal directions. So coming over here now with the GeoGebra, if I go in and try to change this up by putting an A, remember we need an explicit time symbol. I come up here, put a C times X minus an H, and then out at the end put my plus K, and I hit enter. Nothing really seems to happen. And if I unclick, nothing seems to happen. If I click back in that box, there really just doesn't seem to be anything going on. GeoGebra didn't recognize those changes I made as wanting to have new parameters. So I found that what I actually have to do is to go in and type out from scratch the formula that I'm wanting there. I'm going to put an explicit time symbol before the parentheses so that it realizes I'm not writing function notation C of x minus h. And now it created those additional parameters that I wanted that I'm then able to go and change. These parameters can have all sorts of values, positive, negative, 0, 1, etc. Potentially. So I'm not going to actually go in and change the settings on those for right now as I explore. But you do want to go in, set whatever particular base you want, and then you can play around with how the other parameters change that graph. One final suggestion that I have is that you may want to go in and take those parameters that are coefficients, what I would sometimes call a scalar in calculus, and set them at 1, and take the other parameters that are constants that are being added and set them at 0. That will then give you the original first graph that you're wanting to mess with. For example, if I wanted, say, 3 to the x, I now have my graph f is equal to 3 to the x, and g is equal to 1 times 3 to the 1 times x plus 0, all plus 0. So it's the same graph. And then from there, perhaps only change one parameter at a time. Try to see how that affects the graph, just that one parameter, then set it back, change another parameter, see how that affects the graph, and just do it one at a time first to get a sense of what's happening. And then later you can go in and change several of them all together as you're exploring further.